All right, we are about to go on a pretty wild ride. We're going to start with what seems like a simple physics question and end up staring right into the edge of reality itself. Let's see how asking about gravity can somehow lead us to the very beginning of everything.
So it all kicked off with this question from the subreddit, Explain Like I'm 5. Seems pretty straightforward, right? A classic science question. But what happens next is this amazing tumble down a rabbit hole into one of the biggest mysteries in physics.
And there it is. That's the moment. The person who asked the original question gets a few answers and then realizes, wait a minute. To understand how gravity messes with time, you first have to ask a much, much bigger question. This is step one. So, to tackle that question, what is gravity? A lot of people turn to a classic analogy, one that tries to make this huge cosmic idea feel a little more, manageable. You've probably heard this one. It's the go-to explanation. The idea is that space-time isn't just an empty void. It's more like a giant, four-dimensional, super stretchy sheet. And heavy things, like planets or stars, they're like bowling balls that you place on that sheet, causing it to bend and dip. And this is how you connect the warping of space to the slowing of time. See, the speed of light is a cosmic speed limit. It's always constant. So if light has to travel a longer path down into one of these gravity wells, something else has to give. And that something is time. For us looking from the outside, time literally appears to tick slower down there. It's a pretty neat way to picture it, isn't it? But just as quickly as this explanation gets offered up, other people jump in to point out a pretty massive flaw in its logic. And this is the absolute crucial point. The whole analogy is circular. It only makes sense to us because we already understand that if you put a bowling ball on a trampoline, it's going to sink. But the real question is, why does it sink? Exactly. The answer is gravity. The analogy is using our everyday experience of gravity here on Earth to explain the very concept of gravity out in space-time. It's a complete loop that doesn't actually answer the question at all. It just kind of repackages it. And this little critique doesn't just poke a hole in a Reddit comment, it actually points us straight toward one of the biggest, most fundamental unanswered questions in all of modern physics. And that's the honest-to-goodness truth. We can describe what gravity does with incredible mind-boggling precision. We can predict the orbits of planets, we can map how light bends around black holes, but the fundamental why, what gravity actually is still a huge mystery. I love this quote because it just perfectly captures how learning really works. You peel back one layer, you think you've got the answer, but all you find underneath is a deeper, way more complicated question. We started by asking about time, and now here we are, right at the humbling edge of what we as a species just don't know yet. So let's peel back that next layer, which takes us to a place that's even more fundamental. This whole mystery about what causes gravity forces us to ask about cause and effect itself. I mean, does every single chain of events really need to have a beginning? Now, to really tackle this, physicists bring in some pretty formal concepts from logic, and a recent paper dives into this with an idea called a well-founded relation. That's a fancy way of asking, does the universe's timeline have to have a start? Does the chain of cause and effect have to stop somewhere? Is there a very first domino? So which one describes our universe? Is it story like a family tree, where you can always trace it back to a single original ancestor? Or is it more like a circle, with no real beginning or end, where you could just follow the chain of cause and effect backwards, forever? And here's the paper's absolutely striking conclusion. Our common sense assumption, the idea that the universe must have had a starting point, a first cause, well, that idea actually seems to break both physics and logic. Okay, so let's dig into that. Why is this idea of a beginning, something that seems so obvious and intuitive, actually so incredibly problematic for physics? So here's the paradox you get stuck in. A first cause can't exist inside of our spacetime, because by definition, every point in spacetime has stuff that came before it. Okay, so what if you put it on the absolute boundary, the very first moment? Well, then you get something called a singularity. And a singularity is a point of infinite density where all the laws of physics that we know and love just completely fall apart. This leads to an absolutely incredible conclusion. If a first cause does exist, it can't be explained by the physics of the universe that it created. It would have to exist somewhere else entirely, in a realm beyond our whole understanding of space and time. Okay, so if a simple classical beginning runs into all these problems, what's the alternative? This is where we have to ditch our everyday logic and dive into the totally strange world of quantum cosmology. What if the universe didn't start with a bang from a single, infinitely dense point? This graph shows an idea from quantum mechanics. It's called the wave function of the universe. Now, look closely at the very beginning on the far left. The wave doesn't spike up to infinity, it's finite. This is a wild idea that suggests the universe could have just emerged smoothly from a quantum state without that physics-breaking singularity we were just talking about. This idea just completely reframes the entire question. Maybe the universe didn't begin in the way that we think of beginnings. Maybe it just is. Asking what came before the universe might be as meaningless as asking what's north of the North Pole. The question itself might not make sense.
And look, if you're feeling a little bit like this Reddit user right now, that is completely normal. This is what it feels like to be right at the edge of human knowledge, wrestling with ideas that push our brains to their absolute limit. It's not a sign that you're failing, it's a sign that you are truly, deeply engaging with the mystery.
And that leaves us with one final thought. We started this whole thing with a simple question about gravity, and we ended up here, thinking about a cosmos that maybe had no true beginning. So what does it mean for us to be a part of a story that might not even have a first page?